Nda. Hello, how are you?
I'm good, fine, thanks. And how are you?
I'm good.
Yeah, remember our last class was unable to record and we were facing the issue. So I'm going to re-explain what we did to the previous class. I know we have agreed that we're going to start from where we ended on the last class. I mean, we're going to start it over because it didn't allow us to record. You still remember? So I will quickly just go through everything that we did on our last class so that we don't waste much time on it. Anyways, this probability is our second class. We have already explained that if all the outcomes of an experiment are equally likely to occur, you can calculate the probability of an event occurring using the formula P at E is equals to number, total number of an event or total number of a favorable outcome divided by the number of a sample space, which is a total. So where P at E, it means the probability of event E occurring. If here we put A and they say P at A, it's simple going to be saying that the probability of an event A occurring, but now because it's E, we're going to say probability of event E occurring. N at E is the total number of favorable outcomes. N at S is the total number of possible outcomes. So ourselves, we're going to deal with this formula, which says that P at E is nothing but equals to total number of an event divided by the total number of a sample space. Are we still together?
Yes.
Can we go to the next slide? Remember, we are re-explaining because we didn't record last time. Those who were attending, they've got these notes. Can we go to the next slide?
Yes.
Okay. We then took the example and it says, the example says, in an experiment, a fair dice is thrown. Remember, when we are talking about a dice, we are talking about something that have got a sample space of 1, 2, 3, 4, 5, 6. Without continuing on the question, we already knows that a dice have got a 6 numbers, which is 1, 2, 3, 4, 5, 6. So on those 6 numbers, we know on the dice we've got the what? We've got the even and the odd number, and we've got a dice can't. A dice doesn't have a 0. If they ask you about the probability of getting a 0, that's an empty set, which means impossible things to happen. Are we good? Now, guys,
Yes.
are we still together?
Yes.
Okay. So now, as far as we're concerned, we say that the question says, write down the sample space. Sample space is the total number of everything, total number of everything for the experiment. So we have already said that a sample space is represented by the letter S. On the dice, we've got 1, 2, 3, 4, 5, 6. Then this is our total number of what? Of sample space. If you have got a question, you must ask before we just proceed with the lesson. And they say that on number B, determine the probability of getting a 5. Probability of getting a 5 On the event, on the sample space, number of our event 5 is 1. We have got 1 5 on this event, which is this one. So the probability of picking that number, we've got 1 chance. Out of how many chances? Out of 6 choices. 1, 2, 3, 4, 5, 6. We've got 6 choices. So to pick up 5 is 1 out of 6. The third question says, determine the probability of getting an odd number. Odd number is the number that goes with what? Is 1, 3, 5, 7, 9. Is that so? Those are our odd numbers. So how many odd number do we have in this sample space? So we've got 1, 2, 3. It means we've got 3 choices out of how many choices? We've got 3 choices. And it means probability of an odd number is equals to number of event divided by the number of sample space, where the number of event is 3, the number of sample space is 6. So whereby when you press your calculator, you're going to get 1/2. Can we move to the next question?
Yes.
Then they
Yes.
say that if event E is getting an even number is the number that it's like a multiple of 2, 2, 4, 6, 8, 10. So those are our even number. And here we've got how many even number? 2, 4, 6. There are 3. So it means the probability of getting an even number is 3/6, which is 1/2. It's a half. So ourselves, we must also know that our probability will always occur between 0 and 1. Probability will always occur between 0 and 1. So they say that on the next question, determine the probability of getting a number that is greater than 6. On our number simple space here, do we have a number which is greater than 6? On our sample space, do we have a number which is greater than 6?
No.
We don't have any number which is greater than 6. Then a simple means that the event of getting a number which is greater than 6 is equals to empty, is this one. It's represented an empty, which is 0. So it means number greater than 6 is how many event is 0 out of how many? 6, which is giving us 0. And we move to the next question. The next question says determine the probability of getting a number less than 3. We've got how many numbers less than 3? 1 and 2. So there are 2. It means our event is 2. Then the probability is going to be 2/6. Where on our calculator is going to be 1/3. Then we go to the next example. On the next example, they say in an experiment, 8 balls numbered from 1 to 8 are placed in a bag. Write down the sample space for the experiment. They said how many balls? 8 balls. So our sample space is 1 to 8. Are we together?
Yes.
Our sample space
Yeah.
means 1 to 8, since we're talking about the sample space of that one. So now, Photogena, no, Tora. So now, if they say if A is the event drawing a prime number, determine probability of A. So drawing a prime number, what are the prime number value? Let's discuss that. What are the prime number? What are the prime number? What do you understand by prime number?
The prime number in this situation, the 2, 3, 5.
Yeah, but what are the define a prime number?
Well, a prime number basically it's a natural number and it's greater than 1.
So you said it's a natural number greater than 1.
But it can be multiplied by anything to produce that exact number. So basically it's not a perfect square.
The prime number is the number that can be divided by 1 and itself only. That's the prime
Yeah.
number.
Yes.
Are we still together? Prime
Yes.
number ni nomboro dzine dza dividwa ngayo neine na 1 fhedzi. So it means we've got 2, 3, 5, 7 in this situation, as you have said. It means our probability of getting a prime number, which is A, is 4 out of how many sample space it have got 8. And this loop your mic. So now, they say if B is the event drawing a multiple of 2, determine the probability of B. The multiple of 2 is 2, 4, 6, 8. Those are the multiple of 2. Is also 4 out of what? Out of 8. Then now we proceed. They say that the probability of odd number, we know odd number. Our odd number is going to be odd number is the one that we would do in it. That's all.
Yes, sir.
So it means our odd number we have got 4. Then the last question says what? The last question says if D is the event drawing a number greater than or equals to equals to 6, we determine the probability of getting D. So it means greater or equals to 6, we're going to count all the number that are greater or equals to 6, and we find that is what? We find that the numbers are 3. Is that so?
Yes.
Yes.
So can we proceed?
Yes.
Okay. So now, let's talk about what we call a Venn diagram. A Venn diagrams. So a Venn diagram, those are Those are graphical way of representing a sample space and its event. A Venn diagram uh, a graphical way of presenting a sample space and its event. Graphically way of presenting and its event. So let's take an example and see. On how do we write or draw a Venn diagram? Is the question visible?
Yes.
Okay, there we go. Well, they say that suppose 9 cards are placed in a bag with the number 1 through to 9. Write written on them and a single card is selected. They say write down the sample space for this experiment. Sample space for this experiment. How many cards do we have?
9
Hello?
cards.
9 cards. So it means our sample space is 1 to 9. Are we fine?
Yes.
Yes.
Number B, they say write down the set of event A, selecting a number less than 5. Set of event A, selecting a number less than what? 5. It's 1 to 4. Is that so?
Yes.
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 Those are the numbers that are less than 1 to 5. Then number C, they say write down the set of event B, selecting a number greater than 5. Greater than 5 is 6
6
to
to
9.
9.
Yes, 6 to 9, 7, 8, 9. Because they say they didn't say equals to 5. They say greater. Are we good?
Yes. Yes.
Yes.
So
Yeah.
they say that illustrate the above information on a Venn diagram. The above information. It means we're going to have two circles. Do those or did A and B share the same numbers?
No. No.
No. It means our circle are not going to be closed to each other. They are not going to have what we call the intersection, by the way. They are not going to intersect. This is our first circle, and this is our second circle. This is our A, this is our B, and our sample space is 9. So on circle A, we've got a number 1, 2, 3, 4. Is that so?
Yes.
Yes.
And here we've got a 6, 7, 8, 9. Is that so?
Yes.
Yes.
So from our sample space, is there any number that it didn't fall any other number? Is there any number that didn't fall on either event A or B? Is there a number that we didn't write on A or B from our
Yes.
sample space? Yes.
Yes.
Is which one?
Yes.
It's
5.
5.
It's 5. It means 5 is outside. It doesn't follow either in A or B. Then you are done. Are we satisfied?
Yes.
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 So the fifth question says what? Says calculate the probability of A. Probability of A. We know that probability is nothing but equals to the number of events divided by the total space. How many numbers are there in A?
4.
Over total space is 9. Is that so?
Yes.
Yes.
Then we go to the second question. They say calculate the probability of B. How many numbers are there in B?
4. 4.
This is 4 over
9.
9. Number G, they say calculate the probability of A or B. We know the probability formula. Is that so? Probability of A or B. We know that is nothing but equals to probability of A plus what? Probability of B
Probability of B.
minus probability of A and B. And here they didn't meet, so it's 0. Should we write minus probability of A and B?
No.
Why are we saying probability of A and B is 0? They didn't meet. Is that so?
Because there's no intersection.
Yes, if there's no intersection, we call that probability a mutually exclusive.
Exclusive.
Then when you press your calculator, you get what? 8 over
9.
9. If there is no intersection, we call that probability a what? A mutually
exclusive.
exclusive. Yes. Are we good?
Yes.
Can we continue?
Yes.
Mm.
Okay. So now, as far as we're concerned, let's go to the next question. What is the probability of an independent event? We said probability of A and B is equals to what? Are you guys studying? Hello.
Hello.
Are you
Hello?
guys studying? Are you studying?
No.
Do you study? Takaro, do you study?
Yes.
What we said the probability of A and B equals to what in an independent event? Mushom,
Da.
on an independent event, the probability of A and B is equals to what?
Titu you wanna.
Tendani,
Ah,
on an independent event, the probability of A and B is equals to what?
on a what?
Independent event.
Mm, it's occurring.
Did we talk about independent event?
I don't think so.
Okay, but did we talk about mutually exclusive?
Yes.
Yes.
Did we talk about complementary event?
Yes.
Then it means even independent we did.
It's equal to 0.
Independent. Can you go through your notes? Did you find independent?
I can't find it.
Okay, we'll see what you do. Okay, now let's proceed. As far as we're concerned, here is a question: is it divisible?
Yes.
This is suppose 18 discs are placed in a bag with the number 1 through to 18 written on them, and a single disc is selected. Write down the sample space for the experiment. What is our sample space?
1 to 18.
1 to 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Those are our sample space. They say write down the set of event A, selecting an odd number. Let's go, guys. Event A, selecting an odd number is equals to
1,
what? 1,
1, 3,
3,
5,
mm-hmm,
7,
mm-hmm.
9, 9,
Now. You said what?
7, 9,
Oh, 9, mm-hmm,
11,
11,
13,
18,
15,
15,
and
7.
17.
and 17. Yes, I write down the probability of event. You write down the set of event B, selecting a multiple of 3. Let's go.
3,
3,
6,
6,
9,
9,
12,
12,
15,
15,
and 18.
and 18. That's the multiple of what?
Of 3.
Of 3. So they say illustrate the information in a Venn diagram. Can we go to the next slide?
Yes, sir.
Okay. So we're going to illustrate that information. On a Venn diagram. Is event A and B sharing numbers? Hello?
Yes.
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 Okay, it means our cycle must intersect. We've got event A and we've got event B. So on our event A, we're going to have which numbers? Which numbers are they sharing? Let's start to mark those numbers. It's 3, is that so?
Yes.
3, 9, 15.
3, 9, 15. So it means we've got 3, 9, 15. So outside it means we're going to have what? We're going to have what? We're going to have 1, 5, 7, 11, 13, and 17. Are we good?
Yes.
Yes.
Then at this side, it means we're going to have only what? 6, 12, 18. And all the numbers that didn't fall anyway, they are going to be written outside the cycle. Which one are they? We've got what? 2, 4, 8. Is that so? 10,
Yes.
14, and 16. Then you are done with your Venn diagram. And the sample space is what? Is 18.
18.
When we count, those numbers must be 18. Are we fine?
Yes.
Okay. Let's go to the next question. Let's calculate the probability of A. The probability of A is equals to how many numbers are there in A?
9 over
Numbers.
18.
Yes. 9 over 18, which is
1
1
over
over
2. 2.
1 over 2. Then the probability of B,
6 over 18.
6 over 18, which is equals to
1 over 3.
1 over
1
3.
over 3. On G, they say that calculate the probability of A or B. We use a what? A formula. We use a formula. Probability of A or B is nothing but equals to probability of A plus probability of B minus probability of A and what? So probability of A is nothing but 6 over 18 plus probability of B is what? Hello? Are you following?
5/6.
Huh?
5/6.
Is it 5?
Kwamba yonotangana.
Probability of B
No, 9/18.
is 3. Over 18. Oh, this is A only. When we're dealing with a formula, we choose A only. That's why I said it's 6.
Oh, okay.
Plus this minus the did you see that?
Yes.
But okay, let us not to jump off. Let's use the normal one. Is what? Is 9 over what? 18 is that so? Plus 6 over 18 minus what is the intersection probability? Is 3 over what?
18.
Yeah. Now you are satisfied, right?
Yes.
Yes.
Then you get what? 12 over 18,
2/3.
which is equal to 2 over 3, yes. Is this thing difficult?
No.
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 So now, uh, it means, yeah, those things for independent. Is there any question that I have sent you talking about the independent? Let me verify. Because if there is no any question that I send you talking about independent, it means you will meet independent in grade 11. Are we fine?
Yes.
Yes.
Mm, I'm still checking things first about your independent thing. I don't think so. You only use mutually exclusive. Yeah, you are sorted, guys. Means I was mixing you with grade 11, but you are sorted. Are we fine?
Yes.
Yes.
So
Yes.
this is your end of you. This is the end of your probability. It's a grade 10 probability. So in summary, we talked about what we call mutually exclusive event. When you hear the words mutually exclusive events, what must come to your mind is just that in this formula, when we're dealing with a mutually exclusive event, the additional formula, it says probability. In fact, probability of A and B, which is equals to probability, it can be written of like this, A and B. This is equals to 0. Are we good? This is what we call the mutually exclusive. There is no intersection. Row 13.
Yes.
Yes.
So again, we talk about additional formula, the one that we're using. Additional formula, we said the state that probability of A or B, in some of the book, you will find it written, okay, I will just write or in this formula, is equals to probability of A plus probability of B minus probability of A and B. Or in other book, it can be written as probability of A or B is equals to probability of A plus probability of B minus probability of A and B. That's what we call an additional rule. And again, we talk about the complementary event. Complementary events. So in complementary events, we know that we're talking about the probability of not A, which is nothing but equals to probability of A complement. It can be written like this. This is nothing but 1 minus probability of A. And lastly, we talk about the formula for probability. We know that our self-probability of an event is equal to number of an event divided by the number of what? Of sample space. Are we fine?
Yes.
So this is what we call our probability. So the rest, we will also try to do some questions like that so that we can see whether you guys you are following or you're just agreeing. Do you have any questions?
No, not on my side.
Oh,
Guys, let's talk.
Oh, okay. Una question in
Let's use English so that others can be able to understand what we are saying.
okay. Um, when we were writing some few questions, but they were inserted or on a test, like it's a weekly test. There was this question that was saying a card is chosen from a pack of 52 playing cards, and then it says find the following: the probability of hearts, probability of red cards, probability of king or queen. Like, uh, I don't know how to explain it. Like,
So
it means
do you understand the cards?
no, I don't understand them because I don't even play them. That's the
No,
problem.
to understand the cards, it doesn't mean that you play them. I do understand it and I don't play them. It means you understand probability. To understand cards, I know it's a school thing, it's a probability. It's a cards. Even on Google, you can go and say cards. It will give you a playing cards. Because on playing cards, we've got 52. So we'll go for that one in 5 minutes and see. It doesn't even need 5 minutes, it needs 2 minutes, that one. So let's check this out first. Can you be able to answer a question like this, you guys? They say in a random physical sciences experiment A and B are two different events, it was found that probability of A is 2 over 5, probability of not B is equals to 3 over 8, and the probability of A or B equals to 5 over 7. They say calculate the probability of B. Simple. Is that so? What is this? What are we given about B? It's a complement. Are we good? Guys, are you there?
Yes,
Yes.
What do we know
Yes.
about the complement rule? Probability of not B, it must be equals to what? 1 minus probability of what? Of B. And we're given probability of not B. We are going to substitute 3 over 8 is equals to 1 minus probability of B. So we have to solve for probability of B. Are we good? Then we take probability
Yes.
of B that side, the 3 over 8 that side, because that one is a positive, that one is a negative. Then it's going to be 1 minus 3 over 8. Therefore, you got probability of B is equals to what?
5 over 8.
5 over 8. Can you see that they are beating you with all your knowledge? They give you a complement. They know that you have to substitute on a complement formula. Did you get it?
yes, sir.
Now they say find the probability of A and B. Now you know the probability of B, you know the probability of A, you know the probability of A or B. So we have to go for a formula. Are we good?
Yes.
We're going to say, should I go to the next slide or should I write it here? Is it fine?
It's fine.
We're going to say probability of A or B is equals to probability of A plus probability of B minus probability of A and B. So ourselves, we need that A and B. We're given probability of A or B, which is 5 over 7, is equals to probability of A, 2 over 5, plus probability of B, we get 5 over 8. Then minus probability of A and B, that's what we need. So we take probability of A and B that side. And we take 5 over 7 that side. 2 over 5 plus 5 over 8 minus 5 over 7. Therefore, we get probability of A and B is equals to what?
Eighty-seven divided by 280.
80.
87 divided by 2.
87
Yes.
Yes.
divided by
280.
28.
280, which is 0,
0.31.
31. Good. Let's go to the last question, 8.1.2. They say, hence, determine whether A and B are mutually exclusive. What do we know about mutually exclusive?
There is no intersection.
The probability of A and B equals to 0. There's no intersection. Are we good? So they are not mutually exclusive because we go to probability of A and B equals to what? 0.31. Is that so?
Yes.
So we're going to say what? Not mutually exclusive. The reason probability of A and B is not equals to 0. Is it difficult?
No.
No.
Is there anyone who can now tell that they don't understand what we call probability before we end?
No.
And is there anyone again who don't understand cards?
Yes.
You don't understand cards, you guys? Hmm?
Yes, we don't.
Okay. Want to see if I can make something that will make us understand them. Give me 1 minute. Okay. There we go. Those are our cards. Are we fine?
Yes.
So by looking at those cards, you can tell that we have got 1, 2, up to 10, 11, 12, 13. We've got 13. Is that so? If we are talking about a spade, there's a 13 spades. Can you see that here?
Yes.
If we are talking about heart, there's a 13 hearts. 3-leaf, there's a 13 3-leaf. Diamond, there's a 13 diamond. So now, each card have got 4 different leaf. Like this one is an ace. They call it ace in number 1. That's a 1. 1 is an ace. So we've got how many ace? 1, 2, 3, 4. How many? 2, 2, 4. So now the total of these cards is 53. Is 13 times 4, 52. The sample space of cards is 52. Are we good?
Yes.
So if they say the probability of getting a heart, how many hearts do we have?
13 hearts.
13.
Yes, it means the probability of getting a heart on a deck is 13 out of what?
52.
52. And the probability of getting a black card is equals to what? How many black cards do we have? We have got 13 plus 13. And those two are black.
Yeah.
Then it means we're going to have how many? 20?
26 over 52.
26.
Did you get it?
26.
Yes.
And they
Yes.
say probability of ace or a heart. This one we're going to use probability formula. This is probability of ace plus what? Probability of what? Of a heart minus probability of ace and what?
And heart.
And heart. What is the probability of getting ace? Well, we've got 4 ace out of 52. Plus heart, we've got 13 heart out of 52 minus. Do we have a ace which have got a heart? Yes, here it is.
Yes.
It means it's 1 out of, they have got the intersection, those two. 1 out of 52. Then you remunerate your calculator.
4/13.
4/13.
Yes, 4/13.
So this is what about cards. Is there any question?
No.
No.
Okay, thank you very much, guys. Let's end here. Please start,
Yes.